Hi guys, let's take a few minutes to finish questions 6 through 10 on this first confidence interval question about the proportion of students at Westfield High School that own an iPhone. So we've built our confidence interval. We're 95% confident that the true proportion of WH students that own an iPhone is between 64.2% and 83.8%. So, as a basis for comparison, TechTimes.com has suggested that 42% of smartphone users in general in the United States have an iPhone. So, does this confidence interval give us evidence to suggest that the proportion is different for the population of WHS students? So literally, I want to compare my confidence interval to the 42%. So first of all, is the 42% in that confidence interval? And the answer is no. So because the 42% isn't in the confidence interval, this suggests that the confidence interval, if in fact we have captured the population proportion for WHS, no matter where that population proportion is within the confidence interval, it's certainly larger than 42%. So does this confidence interval suggest that the population of WHS students in terms of owning an iPhone is different from the overall population in the United States? We would absolutely say yes. And the logic is very simple. Every possible value in that confidence interval is larger than 42%. No matter if we've captured the truth, no matter where the truth is in that confidence interval, I have evidence that it's larger than 42%. So yes, you could say 42% is not in the confidence interval. I suppose you could be more specific and say all of the values in the confidence interval are greater than 42%. All of the possible proportions in the confidence interval are greater than 42% or 0.42. So I wonder if changing the level of confidence might change our conclusion. So understand our 95% confidence interval was built by using 1.96 standard deviations above and below our sample proportion. So I'm essentially capturing the middle 95% of the sampling distribution. Well, what if we want higher confidence? Let's say a 99% confidence interval. Well, what that means is I need to find a new z-score here so that now I'm capturing the middle 99% of the sampling distribution. So to find the z-score, remember what we really have to do though is use a percentile. So to find this z-score, to figure out how many standard deviations I need to go above and below the mean to capture the middle 99% of the sampling distribution, I have to find the z-score that accounts for not just 99%, but also this little tiny bit that I've cut off of the left side of the distribution. So if I'm capturing the middle 99%, that means that I am leaving off the lowest half of a percent and the highest half of a percent. So what I really need to do is include this 99% in the middle plus this half of a percent. So what I need to find is the z-score for the 99.5th percentile. I need to find the z-score, or the number of standard deviations that's so high that 99.5% of observations will be below it. That will capture the middle 99% plus this lowest half of a percent. So what we need to do is go to our applet. Here we go. So in the applet, I'm going to choose probability. So what we are interested in using here is the normal distribution. So I don't want to calculate an area under the curve. Instead, I want to calculate a value corresponding to the left of a particular z-score. So z-scores have a mean of 0 and a standard deviation of 1. That's the easiest distribution that I could use here. And I'm interested in the 99.5th percentile, so I'll put in 0.995, and we'll calculate the z-score. So we'll round that to 2.58. 2.58 standard deviations above and below the mean. That's how many standard deviations I need to go above and below the mean in order to establish a 99% confidence interval. So this z star right here is 2.58. That value goes right here. This tells me how many standard deviations I'm going to go above, and I'm going to go below my sample statistic. The sample statistic was 74%. So we're using the same sample statistic from our data. We're using the same standard deviation. So what we are doing to establish more confidence is using more standard deviations. We're going 2.58 standard deviations below and above the mean in order to establish new boundaries for our 99% confidence interval. So doing these calculations, what's going to happen is it's going to make the lower boundary lower, and it's going to make the upper boundary higher. So 0.74 minus 2.58 of those standard deviations gives us a new lower boundary of 0.611. It was 0.642 before. Now it's down to 0.611. The upper boundary then, if I add the 2.58 standard deviations, the new upper boundary is 0.869. So it's just a little bit higher. It used to be 0.838. So in order to have more confidence, I have to, in sublevel, cast a wider net. I'm trying to use this lower and upper boundary kind of like a net that I'm casting, and I'm trying to capture the truth. Well, if I want to be more confident, if I want to use a method that will capture the truth in an even higher percentage of intervals that I could calculate, then I need to use wider intervals. So here we go. Following the model from number 5, now we are not just 95, but we are 99% confident. In other words, that 99% confident is describing the method. With 95% confidence, we were using 1.96 standard deviations. If I want to be more confident, I need to use more standard deviations. That's the 2.58. So we are 99% confident that the true proportion of WHS students with an iPhone is between 0.611, forgive me, and 0.869. So the last question, this confidence interval is a little bit wider since our level of confidence is higher. We're at 99% confidence instead of 95% confidence. So has our conclusion changed from number 6? So notice in number 6, I was looking for, does my confidence interval give me evidence that the population proportion at Westfield High School may be different from the 42% that is claimed nationally? Well, that conclusion has not changed. So has that conclusion changed? And the answer is no. So even though this confidence interval is wider, the 42% is still not in the confidence interval, or still all of the possible proportions in that confidence interval still remain greater than 42%. So 42% is still not in the confidence interval. So no, our conclusion has not changed. We changed our level of confidence, we made a wider interval, but it doesn't change the conclusion when we are comparing to 42%. Hope this has been helpful.